Hey there. Heapq or priority queue is a data structure that is used quite a bit in FANG or large tech company software interviews. The benefit that Python's Heapq provides is that it allows you to maintain your minimum element as your first element of the array at all times. Let's walk through some examples and it becomes a lot more clear. So you import the Heapq module and you can use a list as the data structure that you perform operations on. Now, instead of using append or pop, you use the equivalent methods that the Heapq module provides. So heap push is the same as append, and heap pop is the same as the normal list pop. The difference is that when you use these Heapq methods, at any given time, your first element is going to be the minimum element. So here I'm adding 5, 2, and 9 in a random order, but the first element of the list right now is 2 because 2 is my minimum here, even though I'm adding it in the middle. The same thing is true for pop. So pop will always remove that first element and returns it. So here 2 is returned. If I do it again, so the next smallest element is 5. So 5 is returned. And if I try to add a bunch more elements down here in, again, random order, so 10, 1, and 3, right now 1 is the smallest one that I have. So if I pop the element, 1 is returned, and the next one in order would be 3. One thing to note is that your list is not, or your priority queue is not sorted. So you're guaranteed that your first element is the smallest one, but there's no guarantee about the rest of them. So we don't know if the index 1 is going to be the next smallest one. When you do the heap pop, a shuffle happens behind the scene, and the next element that you will access, basically the element that gets moved to the first index, becomes the next smallest. But just know that the first one is the smallest. The rest of the elements, we don't know what the order is. And if you're interested in knowing how this happens behind the scenes, you can read more about binary trees and insertion and deletion from a binary tree. In the last example, we started from an empty list and then added elements to it. But we can also start from an existing list and then use the Heapify method to basically convert that list into a min heap. So here, after I convert this list, now my first element is going to be the smallest one, which is 2 in this case. There are two other methods that Heapq provides. One is push pop, the other one is replace, which is the same as saying pop push. And remember, order matters, and each of these just combines a push and a pop operation. So the first one, I am pushing 1 into the heap and then popping the smallest one. So if I push 1 into this list of numbers, 1 becomes the smallest one, and 1 is also removed. So it's basically as if nothing happened. Now, if I do the same thing with heap replace, first the smallest element is removed, which is 2, and then 1 is pushed in. So 2 is removed, and then if I take a look at my list, I have 1, 5, and 9. And the reason that these two methods are provided is that they run faster behind the scenes. Otherwise, they do exactly the same thing as it would happen if you just do two separate operations. So the reason that we use a priority queue instead of a list and then continuously sorting it is just time complexity. Sorting a list will cost n log of n, depends on your sorting algorithm, but n log of n is a pretty good estimate. But adding or removing elements from a priority queue costs log of n. So if I were to just add and remove elements from a list and I didn't care about minimum or maximum, then using a list would be a lot more efficient because that costs O of 1. But if I need to know what's the minimum at any given time, then this cost of log of n is the best I can do as far as we know. If I were to use a list and sort it, every time this sort would cost n log of n, and every pop, so here like I've added 2, 1 is still my smallest element, but if I at any point I pop that 1, then I don't have a way of knowing where is my smallest element until I sort the list again, so I know the leftmost element is the smallest one. So n log of n times however many times we push and pop would be the time complexity. Python doesn't offer a separate module for a max heap. So far we have been looking at a data structure that always maintains the minimum element as the first one. We can just do a little bit of manual work to change that into a max heap, basically keeping the maximum element as the first element of the queue. And I think the best way to go about it is to just multiply everything by a negative. If the list that I'm interested has 1, 5, and 2, basically I'm adding 1, 5, and 2, but I put a negative sign behind them, so I have -1, -5, -2, and when I try to pop an element, I also add a negative sign behind that. So if I run this, the maximum element is popped out of that list, and if I try to pop the next one, and again put a negative sign behind it, the next one should be 2. You can also use a priority queue on objects like tuples or anything that's sortable. Here I have a list of tuples that has the age and names of some people, and this is unsorted for now. I use the Heapify method to convert that into a priority queue. The smallest age that I have here is 22, so that is popped out first. But then after that, I have 2 people who are of age 30. Because that first element is equal for both of these, the second one is taken into consideration. And if I were to sort those strings, Ali starts with an A, Bill starts with a B, so Ali would be basically the smaller element overall. So if I try to pop something out, Ali is popped out first, and then it would be Bill and then John. And instead of calling methods on the Heapq directly, you can also just import the methods that you need. So instead of importing the whole module, I can do from Heapq import Heapify, and in this case I'm also using Heappop. That way I can remove this Heapq dots and directly call the methods that I've imported. So this has exactly the same behavior, it's just that my code is now a little bit more concise and cleaner. Heapq is one of the interviewer's most favorite data structures. Try to see if you can solve the question that I've included for you in the description section. See you soon.